till now we have only dealt with direct current, that is DC. Now we are going to start with alternating current, which is abbreviated as AC. So why it is called alternating current? For some time the current direction will be in one direction, for another time the current direction will be reversed. That's why we call it as alternating current. Okay. So what is the common kind of waveform that we deal with in alternating current? The most common waveform is the sine wave, sinusoidal functions. So it can be a sine wave or a cos wave. Both are called sinusoidal functions. So if this is I of t, so current as a function of time. For a certain amount of time, the current is positive, right? So when positive means it is, let us say it is going in one direction. When it becomes negative, then the current direction is taken to be reversed. What are some other prominent examples? Another example is the square wave, right? For a certain time it will be a positive value, but it will be constant. See, it is constant, okay? And after a while the current direction is reversed, but here also it will be some constant value. Now this value and this value can be different or it can be same, it will depend on the function, okay? Another kind is the triangular wave. So in all of these cases, the common thing is that the current direction is being reversed after a certain time interval. Now you can see that all of these waveforms, these are periodic waveforms. That means after a certain amount of time, the waveform is going to repeat. For the sine wave, if you take, this is going like this, and after this, it will again start behaving in the same way, right? So what will be the time taken for one cycle, right? So this is called as time period T. Similarly for the square wave, this is the time period, right? What about the rectangular wave? This is the time period. So whenever we want to describe an alternating current, we will require to know the time period. Only then we will be able to mathematically describe it. Okay. So for example, we will take the sine wave and then we will discuss the various characteristics that we need to describe the alternating current. Okay. So we will take the sinusoidal wave. Why we are talking about the sinusoidal wave? Because this is the function that we are going to use most often. Okay, it is a very important function. Now, how do we represent a sine function? If you are taking as I of t and this we are taking as t, then a sine function, how do you represent? I of t is equal to the maximum value. So here you can take this maximum value to be Im. What will be the value here? It will be minus Im. Okay. So I of t is equal to I of m sine t. Okay. So whatever will be the time axis here, that we should represent here. But there is one very important term which is called as the frequency. Okay. We need that to be included in this expression. So how to include it? In order to know that, first we will see what is meant by the frequency. Okay. So first we will start with time period. What was time period? It was the time required to complete one cycle. Next, frequency. What is frequency? It is the number of cycles that can be completed in 1 second. So that means if for one cycle the time taken is time period t, then for 1 second how many cycles are being completed? That is f. Okay. So by basic math, f into t is equal to 1 into 1. So we have f is equal to 1 by t. Inverse of time period is going to give you the frequency. And what is the unit of frequency? Unit is given by hertz. Okay, it is short form is Hz. Now another kind of frequency that we will be using is angular frequency. And this is represented by omega. So what is angular frequency? It is the radians per second. Now what is the expression for omega? For this we will go back to this function here. I of t is equal to Im sine t. Now here instead of t, we represent as omega times t. Okay. So in this way, we will be able to include the angular frequency or the frequency in the function itself. Okay. So how is this going to help? So we know that a sine function, it will start from 0. At pi radians, it is going to be 0. It is going to become 0. At 2 pi, it is again going to become 0. And what is the, this is the time period, right? T. After this, it is going to repeat in the same manner. So what will be the value here? Once again, when it reaches 0, it is going to be 3 pi. And after that, 4 pi and so on like that. Now, since we are taking the argument here, omega t is called as the argument of the sine function. Then on this axis also we will take as omega t instead of simply t. So here we have omega t. But from the graph you can see that at t is equal to capital T, omega t is being equal to 2 pi. Okay. So from graph we have omega t is equal to 2 pi when t is equal to capital T. So this means that omega capital T is equal to 2 pi. So omega is equal to 2 pi by t. This is the relation between the angular frequency and the time period. Now what about frequency? We know that 1 by t is frequency. So you can write here, this implies omega is equal to 2 pi f. So this is how angular frequency and frequency are related. So you can write here angular frequency omega is equal to 2 pi by time period, or omega t is equal to 2 pi f. What is the unit of angular frequency? It is radian per second. Okay, so these are three of the most important characteristics that you need to know. Now there is another characteristic which is the initial phase. So what is this initial phase? It gives an idea about when the sine wave is starting. Okay, so for example, if you take the sine wave that we have been discussing till now, this was the sine wave. Now what if it has started not at 0, this is 0, right? So let us say it has started a little ahead of 0. So that means it is starting here itself. Okay, then this is omega t, this is I of t. Now this angle, why it is called angle? Because omega t, if you see, omega is radian per second and t is second. So omega t is what? It is in radians. Okay, so this angle, the time axis, we can consider it like an angle. Okay, it is in radians. So now this is represented as phi, and this is the initial phase. It will give you how much ahead it is starting, or we can take how much afterwards it is starting. It can be a delay as well. So that means it is starting here. Okay. Now how to incorporate this in the expression? So I of t is given by Im, the maximum value, if you are still taking as Im sine omega t plus phi. Okay, this is for this function. Okay, now what if there is a delay? Then if this angle is given by phi, then you will simply replace by minus phi here, because there is a delay. It is starting after 0. Basically the idea is that the argument should become 0, okay, at this point. So if phi is taken as positive here, since t is negative, then this will become, the argument will become 0. But if there is a time delay, that means it is starting after 0. Okay, here omega t will be positive, so phi we have to take as negative. So that's why you use the negative sign. Now finally, one more important point here is, it is not exactly a characteristics, but it is how we represent the axis, this time axis. So we have taken what I of t is equal to in terms of omega t, and here we have taken pi radians, 0, 2 pi radians and so on. Okay, but we can also write as, in terms of t also you can write, but then the values on this axis will become different. Okay, so this is I of t and this is t if you say. Then what will be the, here unit is radian and here unit is in second. So since it is in radian, we are taking the angle. Pi and 2 pi, these are all radians, right? So if we are taking in time with respect to time, then we represent as t by 2 and this is t, because t here is the time. We are representing in terms of time period. Okay.